Hello everyone, this is Amir from Audio Science Review. Welcome to the debunking channel, which seems to be what I have to do every other day as far as videos given your requests. So today we're going to talk about the USB cables. Do they make an audible difference? Do they make a measurable difference? Let's find out. I think there'll be a message for everyone, no matter which camp you're in. First, I want to actually talk to our camp, the objectivist camp, and the notion that the USB is a digital transmission cable, therefore it can't possibly make a difference in the output of an audio device, a DAC, USB DAC. Back in 2017, I ran a set of tests with my old audio precision analyzer, so the display looks a little different than my newer one. And what I did was that I took a Shed Modi 2 DAC, and you'll see me use this DAC often in my videos when I want to show sensitivity to jitter and noise. This DAC is a much older DAC than the state-of-the-art ones that Shed sells today. And it's powered over USB, and it is fairly sensitive to nature of USB. So I can even plug it into one USB port on one machine and then another machine and have the results vary. So when I try to show sort of the worst case susceptibility for noise over USB, I always use the Shed Modi 2. And what I did was that I tested it with the Sonore Microrendu, which is a streamer. So the streamer was a sort of appliance streamer running Linux. And I used a long, cheap, crappy, thin USB cable. It was a 28 gauge cable, and it was 6 foot. And then I compared it to a 6-inch generic cable. So both of these are generic cables, just different lengths. And as you see in here, there's quite a bit of measured difference in here. This is our 12 kilohertz tone that you often see in my jitter test. And the longer cable produced more of these spikes, jitter, noise, or whatever they are, in this DAC. So absolutely we can measure the difference between two USB cables. Anybody who says that our instrumentation isn't good enough to measure such differences is wrong. We can, and I'm showing you right now that we have indeed measured it. At the time, I also had this fancy audiophile USB cable, some random brand from Triad Wire Labs called the UR Link. And it's a pretty short cable, and I compared that to the short generic cable. It actually was worse performance. So just because something's audiophile cable obviously doesn't mean that it's been tested properly and measured properly. So in this case, with this sensitive DAC, the one in red is our fancier audiophile cable. Even though it's short, it still produced worse performance. Nothing much, but it was measurable. And then I finally had this little stub USB cable, which is just, goes from one to the other with no length between the two. It's rigid. And we see that the rigid one is actually better than the even the short generic cable that I had before. So length is your friend in here. The longer the length is, the more ground loops you create between the devices on your computer, and those can bleed into the DAC and cause interference and cause noise. So be careful in saying digital is digital, bits are bits in these arguments, because that argument does not hold. Because USB is carrying data, we are able to extract data reliably in these short lengths. But it's also got power and ground, and that power and ground is used in a DAC. And if a DAC doesn't properly filter that 5 volt before it uses it, and or it's not designed well, and it can get into ground loops with the computer, which happens to always have a noisy ground, you can impact measurable analog output of the DAC. So everything I've showed you is what comes out of a DAC. I'm not showing you what's on a wire. I don't care what's on a wire. I care about whether my end audio product is distorted or not distorted. We're absolutely able to measure with our instrumentation differences between these cables. And turns out the champion is the shortest one. The shortest one has the least amount of voltage drop and least amount of impedance between it, the ground for the DAC, and the ground for the BC. So it tends to help with that, with a DAC like a shed mode E2. I'll skip over these. But this is an important chart. I was lying to you with those graphs, that if you go back to all of these scales, what do you see? Minus 144 to minus 120. So this is still, below threshold of hearing. So I've zoomed way in and then magnified all those variations. If I don't magnify them and I look at the best case and the worst case, this is the difference that you see. Not zeros on top, minus 140 is at the bottom. And look at the difference we're talking between minus 140 and minus 135 or minus 130. So no case can be made of audible difference here. I'm just showing that we have very sensitive instrumentation, and the bits are not bits because we're dealing with analog nature of the voltage and power supply coming from a computer feeding into a DAC. And if you have a DAC that's sensitive this way, you want to be careful about this. Okay? Actually, yeah, I can show you this one. This is on a Behringer UMC 204 HD, very cheap DAC and audio interface. And it actually showed no difference. Even though it's a cheap, low-cost DAC, it actually, you couldn't see the difference. So it took that shed mode. There's one specific sort of unicorn of a DAC that is so sensitive to these things that I happen to know about, and I exaggerate difference. If I just step up to another budget DAC, which is this one, you see no difference. And indeed, if I use Chet's current products or any other half-decent DAC today, you won't be able to show repeatable difference like this. But just know that at the extreme, the argument is right that the cables can make a difference. As with all things, tweaks in high end, there's always some element of truth to them. Of course, they don't bother to measure or even know it themselves. So it takes me to go analyze it and say, here's a bone. You could have put this on your website and show some difference. So anyway, remember, don't say bits are bits. What you want to say is that you want to have a competent DAC, which costs almost nothing to design, doesn't care about these vagaries of USB. And at any rate, anything that's half fancy will also have its own power supply. So for high-end users to go buy these cables makes no sense. What do they think? That their USB interface in their fancy DAC was poorly designed and they needed a better cable? They couldn't do anything internally to fix that problem? Sort of strange imagination. But anyway, fast forward 2 years later, this is 2020, a year ago, I was given a cable from a popular company, Kimber Kable. Has a stupid name of B-BUS USB. Yeah, it is a B-BUS, but come up with a better name if you're going to charge me $60. Now, $60 is nothing for a high-end cable. This is like, to a high-end user, this would be dirt. This wouldn't even be acceptable. USB cables go up to $20,000 now, depending on length or even more. And I'm not kidding. I don't want to tell you the brand and give them promotion, but there are companies that make $17,000 to $20,000 USB cable, and I know people have bought them and claimed that it was night and day. You plugged it in, and all kinds of magical things happen. This cable is kind of I think it's an ugly-looking cable. It doesn't look high-end at all. It looks like a same old cheap cable you buy for $10, and it's got a couple of ferrite cords on them, but otherwise doesn't feel like a $60 item to me. It says you will be shocked when you hear what these Kimber cables can do to your music, for your music. Oh, wow. It doesn't say what kind of shock. Maybe it's electrical shock, I don't know. But if I'm paying 10 times for a cable, I hope so. I hope I get something that's shockingly better. They have an endorsement from Chris Conacher, who runs an old the site that used to be called Computer Audiophile, but now it's called the Audiophile Style, and is an online, you could call it review site. I don't know how much reviewing he does, but it's a forum and discussion, and folks hang out there. He says he's been a customer forever, and he had high expectations for this USB cable. And as soon as he plugged it in, he hears the original recording. I guess with any other cable, he was hearing something else. What that something else is, I don't know. Says, I can't recommend it enough. It's very inexpensive for high-end quality. It is, as I explained. For $50, such an improvement is no-brainer. So there's some improvement. Quit listening to interference. Really? I listen to USB cables all day long. I don't hear interference. I don't measure interference. Somehow I was hearing interference before. And trust me on this one. Pick up this cable, and if it does what it does to his system, well, he says it'll do the same thing to your system. Wow. We're supposed to trust folks. I wish it was so easy. I wish I could just tell you, trust me. Don't waste money on this cable. But my style is when I give you information, when I give you opinion, I like to be able to back that opinion with something. Trust me, what does that mean? Why should I trust you? What are your qualifications in hearing interference in a USB cable? Let's demonstrate that. Let's see you prove that your ears are that great. Anyway, I'll go ahead and test this using my modern audio precision analyzer. I'll plug in a modern DAC, state-of-the-art DAC, but hey, still a cheap DAC is, I think, top in D90 for a $500 DAC, I forget. So not high-end by anybody's high-end standard, but, high-end by our standards. We plug in with Kimber Kable, spelled funny, and we see the superlative performance of this DAC. Distortion is below 130 dB. Noise floor is almost falling off the bottom of my chart. It puts out 4 volts as we ask it, 4.058 volts coming out. Distortion plus noise is 0.000094%. So you got 2 more zeros to it as a ratio. We convert that to SINAD, we get 121 dB. So at least 5 dB better than threshold of hearing, and it's even better than that. I'm not going to get into psychoacoustics right now. So this is exceptional performance. So I then switch that out and use what I use, which is this Amazon Basics USB cable. It's very supple, which is what I like. I do a lot of removing and plugging things in and everything, and I like to have my cable feel good. And it's got nice connectors on it, and I really like it. I don't like some of the other varieties they have. I like this USB-B cable. I've gotten their other USB, micro USB, and I didn't like that. But for regular Amazon Basic, doesn't get more generic than this, right? I'm sure Amazon didn't do any audio surveys with that. So I plug that in and look at the distortion again. All these zeros, 9, 4. What was it before? All those zeros, 9, 4. Even this right-hand digit did not change. I mean, imagine if I just blow on that machine, I'll probably make enough of a change, digit to change, but did not change with that, with this swapping cable. Look at the output voltage, 4.058 volts before, 4.058 volts before, 1 millivolts accurate. Frequency, dead on accurate, dead on accurate. Gosh, I mean, where do you hang your hat on? You look at the spectrum display, it's identical. Noise, interference, distortion, all of that is encapsulated in this measurement. The full transfer function of the device, not a thing has changed. A bugaboo is jitter. People think, oh, there's noise over USB. That noise goes into a DAC and creates jitter. Noise can cause jitter, so don't say that can't happen. If you don't clean up that 5 volt and you take it and feed it as a reference to a DAC, it can actually cause modulation of the output, and it will create symmetrical tones that you'll see around the main tone. We actually do have some jitter in this product. We can see them. But guess what? Amazon Basics cable or Kimber B cable, identical. They're landing on top of each other. You just can't separate them. I mean, this is a stress test designed to bring out jitter if it exists. It's high frequency tone, which exaggerates jitter. The higher the frequency, the more jitter. Same amount of jitter, the higher this amplitude is. It's proportional to frequency. And we still see no difference whatsoever. Even this little tick here, whatever this is right here, that was also reproduced. I mean, nothing has been removed with this other cable, and as it should be. This is when you buy a proper desktop DAC that I recommend to you, it does all this stuff. They know USB is not clean. I mean, it takes 2 seconds to put a scope on a USB cable, find out it's not clean. Well, you don't use that voltage as is. You bring it in. They have DC to DC converters that convert that to other, or in this case, may not even use the 5 volt off of a USB anyway. And isolation is provided between the USB interface and the sensitive DAC so that the noise that arrives over USB cable doesn't jump and pollute the output of DAC. That can happen. That's what I showed you with the Shed Modi 2. Here, it doesn't happen. I can take a $99 DAC and show you the identical result. So don't fall for this. So I have some explanation in here, but I've already talked to you about that. You can get noise if you have really, really poor DAC, but even then I can't make a case of audibility until you break the device where the packets are falling on the floor, and in that case, it's great static, actually. It's not that the sound state changes, veils removed, things are more analog-like. All of that, when people sense those things, it's just manufactured by this creative mind. The mind loves to make up things. I mean, we have so many neurons in there, and we'd love to think we're also right about all these things. It's just the human nature where we're self-confident, and that keeps us from being always depressed, thinking we're going to die. And so we manufacture improvements in sound readily with our brain, and when we plug in a new cable, we say, wow, look at this, I paid more attention, it sounds better. And then you take it out and you program yourself thinking that the old cable must not sound as good, and indeed it won't. So there is some element of truth in there between USB cables, but as soon as you go, in anything decent these days, it just simply is not material. All these high performance measurements that you see that I show you, I use that Amazon Basics cable, where I'm showing you measurements down to 160 dB. How am I able to keep the noise so low? How am I keeping the interference from the analyzer? The source I use, by the way, this is not some fancy source. This is my everyday workstation that's running right now, my streaming app. My audio precision analyzer has a CPU pig app that runs, that sucks one core dry. And there's activity running. This is my everyday machine. I may have email running, all the stuff's running, Photoshop running, and yet it's feeding data to on a generic Amazon Basics cable to a DAC, and a DAC's analog output. The final thing that we hear is being captured and analyzed to incredible precision, and yet we don't see any flaws. I mean, these things couldn't be more accurate. I mean, look at these values and tell me, how could this cable make a difference? It absolutely cannot. Why did Chris think there was a difference? Just pure imagination. He just needs to learn how to do a control test. A control test simply says, look, let's just use your ears and only your ears, not your eyes, not your brain, knowledge of what you're plugging into, who the manufacturer is. Let's just your ears. We trust your ears, actually. People say, we don't trust the ears, we trust measurement. No. I trust ears. But I only want to hear what goes in your ear, not what else you synthesize that, oh, you've forever been a Kimber customer and you think their cables are great. So, of course, if you forever think that and you plug in their USB cable and it feels and looks nicer, you say, wow, it made a difference. Yeah, your brain will manufacture that. It will definitely think that. The problems of that effect wears off because it's not real. It's manufactured. It wears off. Have a loved one. I've said this 20 times. Swap cables on you when you don't know. Do it. Listen for a whole day. Listen for a whole week. Do this for as long as you need to do. There's no hurry. We're not watching every day. Just keep a log. Was it Kimber Kable or was it Amazon Basic? Was it Kimber Kable or was it Amazon Basic? Have somebody else switch them and then hide them with a towel or something where you can't see the cable. Simple test. Somebody that believes in this stuff should do this. Bring their log. First, just show us text. We don't even need any video proof. For now, just do this simple test. 10 times you ran this. You waited 1 day, 1 hour, 6 weeks, whatever long you want. There's no restriction on time. We're not there to make you nervous. We're not there to make you stressed out. If the results don't come out the way you think, you don't even have to tell us. You could just chuckle. So there shouldn't be any stress in this blind test. You know, but if you can prove 10 out of 10 times or 9 out of 10 times, you can tell which cable is plugged in, you'll be a hero. You will have changed the laws of physics when it comes to audio. You know, if you just demonstrate that. If you can do it quickly in a few minutes, fantastic. Leave a camera running and have somebody else administer this test. That's single blind. That's fine. Doesn't have to be double blind. As long as that other person doesn't wink at you and tell you what cable's in there, it's as good as double blind. We're not, you know, masochists when it comes to this. But give us something other than trust me. Trust me, this cable's great. Go ahead and cough up $50, $60 on a cable. Why? I don't, you know, give me something to go by. We're not lemmings. We're not stupid. Give us something. These are measurements. Why isn't the manufacturer showing any measurements? What is the manufacturer saying they improved? Why are those improvements not measurable? If they've changed things, how do they know they're building the right thing? If they don't measure, do they not test these things in a factory? How are they testing and what are they testing for? What if their chemistry is wrong that day and they're building a different kind of cable they don't even know? So it's important to measure. It's important to prove your point. Have some backup, have some reason that your opinion should be valid. Anyway, I won't bore you anymore with my lectures. Hopefully you learned something about measuring USB cables and evaluate them. See you in the next video. Bye-bye.